we're going to take a look at key features of functions. So we're looking at a graph and a table, and then we're going to identify these key features on the graph and the table. So first thing we need to do is identify the y-intercept and the x-intercept, okay? But before we can identify that, we need to fill in our table. So our table goes -3 is about 2.25, -2 is about 1, -1 is about 0.25, 0 is about 0, 1 is about 0.25, 2 is about 1, and then 3 is about 2.25. What I was doing is I was looking at my graph and looking at where it went up to where the x values went up to the y value. So -2 up to 1, -1, 0.25, 0, 0. They're like coordinates, 1, 0.25, and so on. Now we're going to try to identify the intercepts. So the first intercept is y. Where do we see it? Well, I see my y-intercept right here on my graph where it crosses the y-axis. I also see it on my table right here. So my y-intercept is 0, 0. What is my x-intercept? Well, my x-intercept is where it crosses the x-axis. I see that actually at the same point as the y-intercept. The x-intercept and the y-intercept here happen to be the same points. What about the maximum? Well, I see the maximum, actually, there is no maximum because the graph goes on forever. There is no maximum. Minimum is the lowest the graph goes, and the minimum the graph goes is actually the same as the y-intercept and the x-intercept. Now, let's look at domain and range. Domain is how far left and right the graph goes, the x values. Range is how low the graph goes to how high it goes, the y values. The domain here looks like the graph keeps going forever to the left and forever to the right. So we use infinity to mark that. It is infinity. It keeps going endlessly. It doesn't reach negative infinity. It doesn't reach positive infinity. For the set notation, we use inequality signs. So it would be from negative infinity less than x less than positive infinity. For range, that's how far low the graph goes to how far the graph goes up. So the graph goes all the way up, but the lowest point is down here. So it goes from 0, it reaches 0 to positive infinity. Again, this is how far left the graph goes and how far right the graph goes for the domain. That's how you wrote it like this. The range actually keeps going up to infinity, but the lowest it goes is 0. Notice the difference that I'm using to reference in my set notation for domain and range. Domain, I used x. Range, I use y. Make sure also I use some highlighters to connect some things. I forgot to do that with my x-intercept and my y-intercept. Now let's look at intervals of increasing and decreasing. Okay, I'm going to use orange to highlight the intervals of increasing. The graph looks like it increases from 0 onward. So again, we're looking at where are the x values in which the graph increases. Now the graph looks like it decreases the opposite, from negative infinity all the way down. So again, we have decreasing and increasing on a graph. That's where this decreasing is where the slope is negative, increasing is where the slope is positive. Let's look at another graph and another table. And we're also going to identify those key features on that graph and table as well. All right, so The y-intercept we're going to identify as where it crosses the y-axis. And the x-intercept, x-axis, maximum is how high the graph goes, minimum is how low the graph goes. Domain are the possible x values, range is the possible y values. Intervals of increasing is where the slope is positive. Intervals of decreasing is where the slope is negative. First, let's fill in our table. Well, here, -3 isn't on our graph, so we can't include that in our table. -2 looks like it is on our graph. However, that is an open dot, so it's not included on our table and not included on our graph. At -1, it looks like our graph's about 2. At 0, it looks like our graph is about 0. At 1, looks like our graph's about 2. At 2, looks like our graph's about 0. And it doesn't get to 3, so it is an x. It is not included. Let's identify these points. Try to connect them on the table in the graph. Looks like the y-intercept is 0, 0. That's where it crosses the y-axis. I'm going to identify that on my graph and on my table. Let's look at the x-intercept. Where's the graph cross the x-axis? Well, it looks like it crosses here. However, that's not included, so we do not include that as one of our x-intercepts because it doesn't really cross there. But it crosses here, and it crosses here. So we have two x-intercepts. One of our x-intercepts is also the y-intercept. It's both. I'm going to go ahead and mark both of those on here as well. Those are our x-intercepts. Let's see if we can identify the maximum and the minimum. The maximum is the highest the graph goes. The highest the graph goes is about here. Maybe that's about -1.25. And looks like the graph gets to as high as maybe 2.1. Okay? The minimum is a little similar. Looks like the minimum is about right here, maybe at about +1.25. Then goes down all the way to about -2.1. That looks like the minimum of the graph, the lowest point the graph goes to. Now let's look at domain and range. So domain's how far left the graph goes. Range is how far right the graph goes. Looks like the graph goes over to -2, but again, that is a not included. And it goes to +2, which is actually included. And in set notation, we write it like this. Whoops, we made a mistake. We would never make mistakes. What mistake did I make? Well, like I said up here, this part is not included. It is not included. Let's make sure we don't make that mistake on a quiz. All right, let's look at the range. The range is how low the graph goes to how high the graph goes. Well, that's why this maximum minimum is really important, because the lowest it goes to is about -2.1. The highest it goes to is at about 2.1. And those are both included. So we'll use equal to here. Notice how I used y to denote y values. Now let's look at the areas of increasing. So it looks like the graph is increasing here and here. It also looks like a graph is decreasing here. Let's denote that with some notation. So for the x values of -2 to about -1.25, the graph is increasing. And then from about 1.25 to about 2, the graph is increasing. From -2 to -1.25, then 1.25 to 2. So where is it decreasing? Well, it's decreasing from -1.25 to 1.25. And there we have it. Key features of the function. Let's see if we can just connect real quick. on our table and our graph. On our table, we can't really mark it because it's not as specific in terms of decimal places, but you can clearly see it on the graph. And you can kind of see it how the numbers are going up and down a little bit. There you have it, key features of functions.